Thermodynamics is a branch of physics that deals with the study of heat, work, and energy, and their interrelationships. It explores how energy can be transferred and transformed, and how these processes affect the properties of matter. The first law of thermodynamics is essentially a restatement of the law of conservation of energy, adapted for thermodynamic systems. It states that energy can neither be created nor destroyed, only transformed from one form to another. Internal energy is the total energy stored within a system at a microscopic level. It includes kinetic energy, the energy associated with the motion of molecules within the system. Potential energy, the energy stored in the bonds between atoms and molecules. du equals Q minus W, where du is the change in internal energy of the system. Q is the heat transferred to the system. W is the work done by the system on its surroundings. Consider a gas in a cylinder with a movable piston. If heat is added to the gas, where Q is greater than 0, its internal energy increases. This increase in internal energy can manifest in two ways. 1. Increased temperature. The molecules gain kinetic energy leading to a higher temperature. 2. Expansion. The gas does work on the piston by pushing it outward where W is greater than 0. The second law of thermodynamics deals with the direction of energy flow and the quality of energy. It introduces the concept of entropy, which is a measure of the disorder or randomness of a system. Kelvin-Planck statement. It is impossible to construct a heat engine that operates in a cycle and produces net work while exchanging heat with a single reservoir. In simpler terms, no heat engine can be 100% efficient. Some heat must always be rejected to a colder reservoir. Example: a steam engine takes in heat from a hot boiler, converts some of it into mechanical work to drive the wheels of a train, and rejects the remaining heat to the cooler environment. The engine cannot convert all the heat into work. Some is always lost to the surroundings. Clausius. Statement: heat cannot spontaneously flow from a colder body to a hotter body without external work being done. In simpler terms, heat naturally flows from hot to cold. To make it flow from cold to hot, you need to do work, like a refrigerator. Example: a refrigerator works by extracting heat from the cold interior and releasing it to the warmer surroundings. This process requires external work, typically provided by electricity. Key points to remember. The first law of thermodynamics is about energy conservation. The second law of thermodynamics is about the direction of energy flow and the quality of energy. Entropy is a measure of disorder and always increases in an isolated system. Real-world processes are irreversible, meaning they cannot be reversed without leaving a trace on the surroundings. By understanding these fundamental laws, we can gain insights into various natural phenomena and design more efficient technologies.